Hey everybody, welcome back. Thanks for watching. I want to prove two trig identities that we're going to use in the next video to prove a really cool geometry result. So first of all, we've got the sine of theta times the sine of phi is equal to the cosine of theta minus phi minus the cosine of theta plus phi all over 2. And then second, we've got this product. We've got the sine of a minus b times the sine of a plus b is equal to sine squared of a minus sine squared of b. And we want to recall the following. We proved these two results in a previous video. So look out for these. And so I think without further ado, let's go ahead and prove the first result here. So in terms of a strategy or a plan of attack, I think we should work with the right side, expand it out using these, and then show that it's equal to this left side. Okay, so let's go ahead and do that. Okay, so for result number 1. So yeah, as mentioned, let's go ahead and we're going to take what was the right side before, and we're going to expand this out. So this is the cosine of theta minus phi minus the cosine of theta plus phi. We said that's all over 2. Okay, so let's think about what we have here. So we're going to have the cosine of theta times the cosine of phi when we expand this out. So just using that formula that we proved previously. So yeah, cosine of theta, cosine of phi, opposite sign, right? So plus the sine of theta times the sine of phi, and then minus, and a parenthesis, right? So let's go ahead and expand this now. So that's going to be the cosine of theta times the cosine of phi, opposite sign, and then sine of theta, and then sine of phi. And of course, that's all over 2. And if you take a look here, so after you distribute, you're going to have some canceling and some like terms. So this will cancel with this, so that's gone. And then one of these plus another one of these gives me 2. So that's 2 sine of theta, sine of phi, all over 2. And we cancel to get our result. So that's sine of theta times the sine of phi. Okay, that wasn't so bad. Okay, so result number 2. So let's just recall what result number 2 said. So this is our next goal. So we want to prove that this is true, and we want to look out because we might use this result in proving this. Okay, let's go for it. So what's our strategy, by the way, for part 2? Let's take this side and expand it out because this very much looks like what we just proved, right? This looks just like this. So let's expand this out using this result, and then we hope to land here. Okay, let's go for it. Okay, so result number 2. And here we go. So we've got sine of a minus b times the sine of a plus b. Okay, so let's be kind of clever here. So we proved that 1 is true. We've established this, right? So let's just think about what's playing the role of theta and what's playing the role of phi over here. Well, it looks like this is playing the role of theta and this is playing the role of phi. So just everywhere I see theta and phi, let's replace theta with a minus b, and let's replace phi with a plus b. Okay, so what would that look like? So I'm going to have cosine of, well, that's my theta, so a minus b, minus, what's my phi, a plus b. So it's exactly this expansion. So this expanding into this part, and then minus, right? So this is going to be the cosine of, again, we said this is playing the role of theta. So it'd be theta plus phi. So theta plus phi. That's all over 2. That's using property 1 from before. If you want to note, that's playing the role again of theta. That's playing the role of phi. Okay, great. Let's expand this out. Okay, so definitely some like terms going on here. So we've got the cosine of, it looks like minus 2b. And then here we've got the cosine of, looks like 2a. So yeah, just combining your like terms there. That's all over 2. Now recall cosine is an even function. So remember that? So cosine's an even function. So what does that mean? It means for all theta, cosine of minus theta is cosine of positive theta. Add y-axis symmetry as well, remember that? Let's use that there, because that's the same thing as the cosine of 2b. Minus the cosine of 2a. That's all over 2. And again, that was using the fact that cosine is an even function. Okay, so now we can use double angle formulas for cosine. So here, we've got some choices here, but I want to land at a statement about sine squares, right? If we do this correctly, we're going to land here. So of all the choices for the cosine of a double angle, we want to choose smartly, right? We want to choose the version with a sine squared in it. So that's exactly 1 minus 2 sine squared of b. Okay, double angle formula, this is equal to this. And then double angle formula, this is equal to 1 minus 2 sine squared of a. So that's all over 2. Okay, so let's combine like terms. So it looks like the 1's are going to cancel. And I've got minus 2 sine squared of b plus 2 sine squared of a. That's all over 2. Now the 2's are going to cancel, and using the commutative property of addition, I can order switch. So that gives us our result. See, I always think these trig identities are really fun, kind of like little puzzles. I remember when I was a student, I used to like just getting lost in them. Sometimes I would take a wrong turn, like in a maze. But it was fun to just try something new and poke around. And sometimes it's cool to prove these using, and you can prove this multiple ways, right? So you might want to try it and do that. And with that said, I hope you liked the video. Please consider subscribing, share the video with your friends. Lots more awesome math on the horizon.